We'll see. All right. Hey, Aubrey, this is 3-2. Is this 3-2? 3-3. I'm sorry, 3-3. Thank you. Here's a homework assignment for this section. Whoa, I just erased it. Homework assignments here, 2 through 20 evens. There are 3 main concepts going on in this section. Okay, and that's it. Okay, we will get done with this today. This is something called deductive reasoning. Deductive reasoning. Okay, here's what we were doing. We were doing inductive reasoning. Okay, write this down. Inductive reasoning. Okay, they're like opposites, right? Reasoning. Okay, inductive reasoning is based upon patterns. Okay, and what we do is we look at a list of patterns, like things, right? Like one of them was like 6, 5.5, 5, 4.5. What's the pattern? You're subtracting a half each time, right? Like that was the pattern. We are taking patterns and we are using inductive reasoning to form them into a conclusion. Inductive means I'm taking all of that supporting information and I'm putting it into a conclusion, right? Which is called a conjecture, right? Do you remember that word? Conjecture, conclusion, okay? That was inductive reasoning. Deductive reasoning is based upon facts. So I am looking at a statement and I am deducing, that's what it's called, deducing information out of it. I'm like pulling information out of it and it is based upon facts. So remember that inductive reasoning is patterns, deductive reasoning is facts. Got it? Inductive reasoning is patterns. Deductive reasoning is facts. I'm pulling out information that is factual. I am not putting patterns into a formula and coming up with a conclusion. Got it? All right. Here we go. Let's talk about example 1. They are asking you whether it is inductive reasoning or deductive reasoning. Okay, what does inductive reasoning mean again? Patterns. Deductive reasoning is facts. Okay, I want you to go through really quick and you decide A and B, read these statements and tell me which one is which. Put them in the blank and then we'll check your answer in 30 seconds. Go. Shh. Just wait. You can put an I or a D. I don't care if you want to be like short about it. Patterns and facts. Colton. Need a foghorn. Okay, whatever. Don't. You're gonna hurt somebody.
Colton.
Shh. Just leave him alone.
Let him sleep.
Okay. All right. Did you get them all done? A, if a student is late returning a book, then he or she will be charged a $2 late fee. Is that just a pattern of like how things go? Or is that like factual information for 100%? 100% you are going to get charged a $2 late fee. That is a fact. F-A-C-T. Chang returned a book to the library late, so he concludes that he will be charged a $2 late fee. That's not based upon a pattern. Oh, I guess I've been charged a $2 late fee every time. No, that's a fact. You are charged a $2 late fee. This is deductive reasoning. Deductive reasoning. Got it?
On the home, can we just write a deer?
I don't care. That's fine. Okay. Every time Tamika has worn her favorite jersey to a football game, her school team has won. Fact or pattern?
Wait, question. It's pattern. But
Yes.
Is this like
Is this English or math?
isn't this like cause and correlation?
Kind of, yeah. Correlation and causation. Yeah. Yeah, look at you go. Yep. Okay, every time Tamika has worn her favorite jersey to a football game, her school's team has won the game. She is wearing her favorite jersey, so she concludes that they will win the game. Inductive or deductive? Inductive. That is wishful thinking. Okay, I mean, I'm not going to tell you that I still wouldn't wear the favorite jersey just as a superstition because I'm not superstitious, but I'm a little stitious, right? Like,
When a black cat runs in front
Little
of you while
bit.
driving, you get a little scared.
you get a little stitious. All right, so deductive, inductive. Questions about that? Fact, pattern. That's it. Okay, next. That was main point number 1. Okay, how many main points do we have? 3. Main point number 2. Here is something that is called the law of detachment. Put a 2 next to him. That's main point number 2. Law of detachment. Okay?
That sounds important.
Law of detachment. It's like something is being detached from something, right? Okay? Here's what the law of detachment says. Ready? There is a pattern for the law of detachment. Put this off to the side. Law of DET. Law of detachment. Here's how it goes. P, Q, P, Q. And I put the Q in a different color. Because sometimes what they'll do is they'll say...
The Q's leaving.
What?
The Q's leaving.
Sure. Right. Okay.
We're leaving
Here's
the
how this
Q.
works. Ready? Okay. Statement P. I'm just verbalizing this to you. So let's see if you can figure this out. Put your feet down, please. Dylan. No. Okay. Law of detachment. Here we go. Here's statement P. This is what statement P says. Shh, listen. Statement P says, if it is raining, listen to this. Statement P says, if it is raining. Statement Q says, then I will bring an umbrella. It is raining today. Conclusion?
Bring an umbrella.
I have brought an umbrella. Does this make sense?
Yep.
Statement P. If it is raining, I will bring an umbrella. Today it is raining. So today, I have brought an umbrella. That's what the law of detachment is. It goes PQ, PQ in that order. Sometimes we have to come up with the Q statement. Let's see how this works. Here we go. Law of detachment. Figure out whether it's valid or invalid. All right? So, given, to go on a field trip, a student must turn in a permission slip. Okay? What's the P part of that?
To go on a field trip.
To go on a field trip. If you want to go on a field trip, right? Like that's the if part. Okay? A student must turn in a permission form. That is the Q part. Okay? Marina turned in her permission slip, so Marina can go on a field trip.
It's a P.
That's the P part. I think we swished this around.
No.
Actually, P should be the permission slip part. We've flipped that around. Because this is the if part. What comes first, the permission slip or the field trip? Yeah, the permission slip. So P should have been that one. Q should have been this one. So Maria turned in her permission slip. That was P. So she can go on the field trip. That's Q. Is that valid or invalid? Valid. Blah, 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 blah. Okay, the phrase, a student must turn in a permission slip, is the conclusion of the conditional statement. So analyze it. Is true or valid conclusion. Circle that. Got it?
No.
Okay, let's see if we can figure this next one out. B. If a figure is a square, that is P. Then it is a polygon, that is Q. A figure is a polygon. Q, does that mean the figure is a square? It's got to go PQ, PQ in that order. If a figure is a square. Hold on, what? The first one did. It went PQ, PQ. It just didn't give it to us in that order. P was actually this part. P, then Q, P, then Q. Because they wrote this statement like in the reverse order. They should have said if a student turns in a permission form, then they go on a field trip. That's what the first statement should have said. They tried to confuse you by putting it in a different order. So you have to figure out the hypothesis and conclusion if they put it in a different order. All right, so this one. If a figure is a square, then it is a polygon. Hold on. If a figure is a square, then it is a polygon. True or false? Do you know this? If it's a square, then it's a polygon. Okay, they're saying that the figure that I have is a polygon, but that's saying statement Q first. Does that mean my figure has to be a square? What could it be?
Rectangle.
It could be, yeah, it could be a rectangle. It could be a kite. It could be a trapezoid. It could be a hexagon.
Triangle.
Okay? The hypothesis, a figure is a square. Then it is a polygon. Analyze the conclusion. They did say it's a polygon, which doesn't necessarily mean it's a square. So valid or invalid? Invalid. Okay, it's got to go PQ, PQ. In that order, it has to be valid.
But it
Yes.
could be figure A is a polygon. That could be the P because it's stating like.
But it has to be true. The original given statement has to be true.
And then the follow has to be true.
Yes, in order for it to be valid. That's the law of detachment. PQ, PQ. Got it? Let's do a check because we're like confused about this, okay? All right, if 3 points are non-collinear, that's P. Then they determine a plane, that's Q. Points A, B, and C lie in plane G. Is that Q or P again? Points A, B, and C lie in plane G. Is that P or Q? That looks like a Q again. They determine a plane. They lie in a plane. They're not. It doesn't say anything about them being non-collinear. Does that mean A, B, and C are not collinear? We don't know anything about them being on the same line. Okay, it's got to go PQ, PQ. This one went PQ, QP. That's not necessarily true. It's trying to say that the converse is true, and it's not. Okay, invalid. Where are we at here? Invalid. Points A, B, and C can be collinear and lie in plane G. D. Okay, next one. B. If Dakota goes to the video game store, that's P. Then he will buy a new game. That's Q. Dakota went to the video game store this afternoon. That is P. Dakota bought a new game. That is Q. Valid or invalid? Yes, that goes in the correct order. Okay? Because, let's see, which one is it then? B or C?
I think it's B.
I'm going to say satisfies the hypothesis of the conditional statement. The conclusion is true. I'm going to say C. Whatever. It's valid. Okay? All right, last one. This is something called the law of syllogism. This is bullet point number 3. You might like this one a little bit better. Okay? This is also called the transitive property. Okay, we'll talk about the transitive property, but here's what the transitive property. The transitive property in algebra says this. If x equals 2 and 2 is equal to y, right? Sometimes you'll have it written as 2 equals y instead of y equals 2. Then what do we know? Then x is equal to y, right? Got it? That's the law of syllogism. Okay? Let me give you a verbal example of the law of syllogism. Who are my... Wyatt, you're old in here. Are you a junior? Okay. Trevin? You're younger than Wyatt. Owen, are you younger or older than Trevin? You're older? Okay. Here we go. Trevin. Younger? Younger than Owen. That's supposed to be a capital O. Trevin is younger than Owen. Owen is younger than Wyatt. Conclusion?
Trevin is younger than Wyatt.
Trevin is younger than Wyatt. True? Can we say that? Yeah, Trevin, younger than Wyatt. Does that make sense? Okay, so let's analyze this. Let's figure out these parts, right? Trevin is statement P. Owen is statement Q. Owen is the Q part. Then in the next line, Owen is the Q part again. Wyatt is R. So our conclusion is that Trevin is younger than Wyatt, which is saying that P and R go together, right? So it goes P, Q, Q, R, P, R, right? Here's how it works. P implies Q. Q implies R. That means P implies R, right? We skip right over the middle person because we don't care about Owen anymore. Sorry, Owen. Make sense? We get to bypass Owen. We go straight from Trevin to Wyatt. Got it? That's how the law of syllogism works. It's also called the transitive property in algebra, right? Okay, let's see if I can figure this out. Example 3. Scientists. All right. Scientists have found that the quality and amount of sleep greatly impact learning and memory. Yes, true. Lack of sleep causes students to have trouble focusing and receiving new information. Sleep deprivation also makes it difficult to retrieve previously learned information. Draw a valid conclusion from the given statements if possible. Here we go. Given. If you are tired, that sounds like P. Then you will not do well on your test. That sounds like Q. If you do not get enough sleep, then you will be tired. What is happening there? Reorder the given statements so the conclusion of the first statement is the hypothesis. If you are tired, then you will not do well on your test.
No, if you are tired, you will not get enough sleep. So then, if you do,
Or if you do not get enough sleep, you will be tired.
if you do not get enough sleep, you will not do well.
So let's do this. Let's order this statement first. Okay? Go off to the side over here. Let's order this statement first. If no sleep, then tired. Okay? If no sleep, then tired. That's the second statement. We're going to write it first. Okay? If tired,
Then bad.
then bad test. Okay? So if we reorder that statement, then we are able to come up with a good conclusion. Go sit down. Sit. I don't care. Sit. Sit. Okay, if we reorder those statements, then we can come up with a conclusion, right? If no sleep, then tired. If tired, then bad test. So what's your conclusion?
If no sleep.
If no sleep, then bad test. There you go. That's your conclusion. If no sleep, then bad test.
So we get a next start.
Okay? Let's see if we got another one. Is there another example? Is that it?
Hey, go back up.
If no sleep, then bad test.
Yeah, please go.
Okay? That's it. 2 through 20 evens. Go.
I have a question.
What?
For number 14,
Yeah?
it says, so in like the section, it says to use the law of the S word.
Law of syllogism. Yep.
But that one, you can't make a conclusion unless you use the other law. So
If two lines are perpendicular, then they intersect to form right angles. So that's P and Q.
would you have to use like the other law?
Lines S and R form right angles. That's like Q again.
So wouldn't it use the other law? Not the law of C.
Correct. So no valid conclusion can be drawn. If no valid conclusion can be drawn, write no valid conclusion. NVC. On 14. Does that make sense? Yeah, there you go. Okay, not enough information. No valid conclusion. All right, goodbye.